Hi, this is Brian Dramus, and this is a short tutorial on how to test and calibrate a phasing meter. In specific, we're going to be looking at the Hastings Model 6706. The first thing that I've done is you'll see a cord running here along the ground. This cord runs outside and is hooked to a grounding rod. So this is my main grounding point. So, going back inside, we'll see that this is where my ground ends, and we'll go through every point. Every ground in this setup is running back to this main grounding point, which is then going back to the grounding rod outside. So, just overall, this is our setup. It's not the ideal setup because of cramped spaces. If you're out in the field, then you may have a little bit more space. So we have a table here that we've lined with a rubber blanket that's been failed just to give a little bit added insulation from ground. We're using 2 sets of hot stick cleaning blocks in order to suspend the phasing meter. This phasing meter that we're going to be using is actually a 6702 model. The model that has been quoted to the customer is calibration of a 6706 model. These are two very similar. The 6702, this model here, will measure from 0 to 40 kilovolts, and the 6706 model will measure from 0 to 20 kilovolts. That really truly being the only difference between the two. So, because of the fact that they're so close in similarities and even how they look, we're going to use this model to kind of use as a guinea pig. So, we'll come around to the backside. You'll see how I've kind of left the blocks on the edge. This gives the hooks enough room to hang off. We don't want too much crowding around these hooks because that may mess up our readings. So we have plenty of space around our hooks. Now these hooks, you're going to have to screw in yourself. It's not difficult. They just screw into the backside. Okay. So this is what we call our non-meter side because it doesn't have our meter on it. The non-meter side, you'll need to attach a ground to it, and that ground will need to run back to our star grounding point back there. Now, our meter side, the stick that has the meter on it, you're going to have to hook up a hot lead to it. And your hot lead is going to run to your high voltage divider tower. And from there, you're going to hook another hot lead from your high voltage tower to your transformer. In this setup, the transformer will be our source of voltage, but not our source of measurement because it's not accurate enough. So therefore, we have to use the high voltage divider tower and its console in order to give us the accuracy that we need to calibrate the phasing meter. So that's why we have the high voltage divider in series with our high voltage meter and our transformer. And this is actually a KVM model, a Phoenix Tech model KVM 200, the same as what's owned by Odessa. So in setup of our tower, you'll see that we have our ground cord, which once again goes back to our star grounding point. And we have our coaxial connecting cable, which connects to our console, which I'll show you all that in a second. Okay, now our console, here's the coaxial cable coming from the tower of the KVM 200, and we also have a ground that comes off the console, and it as well goes back to our star grounding point. Now, our settings on our KVM console, so your power, there's your battery charger. So if it's low or dead and you need to charge your battery, we'll run it on our high range, and we'll want our function set to RMS. We're going to be measuring AC voltage RMS, so we need it to be on our RMS function. You won't need to move off of this function for testing and calibrating phasing meters. This is a backlight turn knob that'll adjust the brightness level of your backlight. And that's all you'll need for this setup. Now, for our transformer, standard setup of a transformer is we've got a ground connected to our ground stud, coming off and going back to our start grounding point, and we've got our connecting cable from our transformer to our console. This is the console of the high voltage model ALT 120/60. We also have our console grounded, and once again, our ground cable going back to our star grounding point. So you see how all the grounds, whether it be from the console, from the transformer, from the KVM tower, from the from the phasing meter, outside, and from the high voltage divider console, are all tied together to this one star ground leading outside to our grounding point. Now, the meter itself. First step that you'll need to perform is check the battery. There should be a 9-volt battery at the top, in the top lid here. Check that battery with the multimeter and follow JM's that's a 9 volts, so it should test at 8.75 or greater. If it's less than that, then go ahead and change it out. That's the JM standard. It's toggle switch back here. Toggle switch back here may be in the normally off position. If you push it to your left, then it'll turn the meter on. If you push it once to the right, then you'll see it turns the backlight on. If you push it back to the middle, it turns the backlight off, but the meter remains on. If you push it to the left and hold it for a second, push it to the left and hold it for a second, then it'll turn the meter off. Stop, stupid. All right, so we've got our phasing meter set up. Once again, get a nice side view of everything. Now, an important note to point out here is that because of the fact that we'll be getting our electricity from our transformer traveling to our high voltage divider tower and then traveling to our phasing meter, this hook will be energized. But a less known fact is that this fitting here will also be energized. This fitting here will also be energized. And this hook here will also be energized. So it's very important to know that, and also this cable will be carrying some current too. So it's very important to know, although this is a safe setup, it's granted not the safest that it could be. It does eliminate the operator from being in close contact to any of these energized points, but it is important to know. All right, so if we'll go ahead and step up to our console, and we'll do at least 1 point. Now, I'm printing out this copy of the data sheet for the Hastings Model 6706. calibration is performed in accordance with JM 134 procedure. It is a high voltage phasing meter that'll go up to 20 kV. The test parameters are going to be AC voltage at 60 hertz, the 0 to 20 kV scale, which is it's a single scale, so that's the only scale. We're going to test at 5, 10, and 15, and you see your upper and your lower acceptable limits there. Now, it may come with a pair of resistors, or 2 or 3, and we'll get to that later. And the operational checks is whether or not the display backlight is working, and that's just simply a pass or fail. So, we have, we're set on our top tap. It doesn't matter whether you're on your low or high. You just need to know where your voltage is going to be coming from. Is it going to be coming from your side tap, or is it going to be coming from your top tap? We have it set on our top tap, so therefore we need it on either our low or high range of our 120 kV tap. We're not concerned as to whether or not it's ground or guard. It can be either, because we're not measuring any current leakage. And your current meter can be in any position, 250 microamps or times 1. Once again, we're not going to be measuring any current leakage, and so the current leakage is going to be very, very minimal. So, because of the fact, once again, that we're relying upon the display of the high voltage divider to tell us how much voltage is coming from the transformer, we won't even need to pay attention to our voltmeter as to tell us how much voltage we're outputting. We're going to go directly off the display of our KVM 200. So, I'll go ahead and turn our console on. Go ahead and turn our high voltage circuit on, and we'll pay direct attention to the console of the high voltage divider. So I'm going to apply voltage, and as I apply voltage, you'll see the voltage increasing. And I'm going to go to our first data point, which is, sorry about that, 5 kV. 5 kV with a low of 4.8 and a high of 5.2. So we'll go back to our console. We're at 4.26 and increase to right about 5. It's going to be difficult to get exactly 5, so you can do the math as well. If you're sitting at 5.3 here and you're at 5.4 here, well, then you can just deduct 0.3 from here and 0.3 from here, and that should put you at 5.1 for your phasing meter. So with a known voltage of 5.3 coming from our read by our standards, we're looking at 5.1 measured by our customer's piece. So going back to our data sheet, we're in tolerance at 5 kV because we're reading below 5.2 and above 4.8. So that test parameter is passing. So what you'll do next is you'll continue through all the test parameters and just write down your readings and whether or not it's in tolerance or out of tolerance. For your resistor pairs, because of the fact that your 6706 meter will only display up to 20 kilovolts, but if you add on extension resistors, you can measure, it will measure higher than that. Then you'll have to take your display reading and you'll have to multiply it by 2 or 3 or 4, depending upon how many pair of resistors there are. So what you'll do is you'll apply 30 kilovolts measured from your KVM display, and what you should see is 15 kilovolts measured on your customer's piece. So That's an important fact. If you run into one that has phasing, add-on extension resistors, you're going to have to take the meter reading and multiply it by 2. Hope this helps you. And if you all have any questions, then you all can call, of course, Susie Brady at her extension, or you can call me. Best case scenario is to get me on my cell phone, 985 507 1295. Once again, that's Susie Brady and Brandon Doremus, and signing off.